next analysis, that is nodal analysis. Nodal analysis. Hello. Manage. So nodal analysis or node voltage method. My voice is now audible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am. Voice is audible.
Yes, ma'am. Audible.
Okay. So nodal analysis or node voltage method. Now here I will tell you the steps. Same circuit which I have done it for mesh analysis. Same circuit we will solve it using this analysis, node voltage method or nodal analysis. Okay. In case of, unlike your mesh analysis where you are finding out the number of mesh, then you are assuming current in each mesh, then you are using Kirchhoff's voltage law and writing the mesh equation, and you are solving the mesh equation. Here same circuit I have taken. This one is E1, E2, this one is R1, R2, this is R3, this one is R4, this one is R5. Okay. So now coming to the different steps, listen first the steps. All the steps you should, while solving the problem using the nodal analysis, all the steps should be present. Okay, so first step is you have to identify how many nodes are there. First step is identify number of the nodes. You identify what are the nodes whose potential is not known. Whose potential is not known. Okay, the potential of that node is not known to you. Now coming to, so first you identify what are the nodes. So this can be, and this is a node. What is a node? I have already told you the definition of a node. What is a node? Yes,
where 2 points meet.
Where two? No, 2 points. Where two? Where?
Ma'am, if is a point in a circuit where 2 or more circuit elements are connected.
Yes, very good. Where 2 or more circuit elements are connected, that is a node. Where 3 or more circuit elements are connected, that is a junction. Okay. So here these are the different nodes. This is a node, this is a node, this is a node, this is a node. Okay. So here you see this node, this and this one. Okay, which I have shown it in yellow line. This is a single node because these all these nodes are short. So this is a single node. But this node, if you consider this one, here a battery is there, E1 is there. E1 is equal to 5 volt, right? Suppose E1 is equal to 5 volt. That means the potential of this is 5 with respect to this one. This is a negative. Okay. This is a negative where this voltage is 0 volt. This one is 5 volt. Okay. So the potential of this node is known to you. That is your E1. Am I clear to all of you? The potential of this node is known to you. That is E1. Similarly, the potential of this node is known to you. That is your E2. E1 and E2 value will be known, given to you. So you can able to know what is the potential of this node, what is the potential of this node. Am I clear to you? All of you, am I clear or not? Tell me.
Yes, ma'am.
Okay. Yes. Everything should be clear. And this one, here you see where more number of nodes are connected, where more number of nodes are connected, this node is taken as the reference node. This is called as the reference node. Okay, and it is usually taken as 0 volt. This reference node is taken as 0 volt. Like this is a 5 volt. That means this is positive, this is negative. That means the potential of this point is 5 with respect to which one? With respect to this one. Am I clear now? Suppose this is at 12 volt. That means the potential of this one is 12 volt with respect to this one. That means this is at 0 volt. This is at 0 volt. Am I clear now? So where more number of nodes will be connected, that one we will take it as the reference node, and that voltage we take it as 0 volt. Am I clear to each one of you? Clear to all of you?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, girl side, am I clear?
Ma'am,
Tell.
ma'am,
Yes,
can
ma'am.
you explain again? I am having some network issues, ma'am. Unable to hear.
So you have to identify how many nodes are there, okay? And this one where no more number of nodes will be connected, that one you will take it as the reference node. That will take it as 0 volt. Like this one is, suppose this one is you are taking it as 5 volt. Okay, that means that is respect to this one. This is equal, this is 0 volt. Okay, so this node is called as the reference node. Am I clear? Who was asking? Am I clear? Who
Ma'am,
was
can you
asking?
again tell, ma'am? No, ma'am, I didn't get it.
What?
Hmm?
Tell me. Yes,
can you
yes. I am
again
not.
tell, again?
So you have to identify how many nodes you know. You identify how many nodes are there. Okay. And one of the node where more number of nodes. This is this point, this one, this node, this node, this node. They are connected to a single node. So this one is taken as the reference node. Am I clear now?
Yes, ma'am.
Okay. So this is called as the reference node, or it is also called as the datum node, where the potential is 0 volt. Okay. So now you have identified the number of nodes whose potential is not known to you. Okay. One of the node you are taking it as 0 volt. Okay. So here we suppose n number of nodes are known to you whose potential is not known to you. So you have to write down n number of equation, excluding this datum node or the reference node. Am I clear? So this is n is the number of nodes. N is the number of nodes whose potential is not known. Is not known. So you have to identify that node. Am I clear now? Now second point is you have to assume voltage to each node, or assign voltage to each node. Assign voltage to each node. Okay. So second step is you have to assign voltage to each node. Now whose potential is obviously, now you will work with the nodes whose potential is not known to you. Okay. So how many nodes are there whose potential is not known to? What is the value of n? Tell me. Quick tell. What is the value of n? Number of nodes whose potential is not known. Tell me. 2. 2. 1. This is 1. This is number 2. So assign voltage to each node and name the node. Assign voltage to each node and name the nodes. Okay. So I have named it node 1 and node 2, and I will now assign the voltage to each node. Let this is V1, this is V2. Understand all of you very carefully. Am I clear up to second step? Second step is clear to all of you? Okay. Now come to the third step. Third step is what you will do. It is using Kirchhoff's current law. Using KCL, write the node equation. Using Kirchhoff's law, write the node equation. Okay. Now while using Kirchhoff's law, when you will use the Kirchhoff's law, tell me, when you will be having the current in the different branches, then only you can apply Kirchhoff's current law, right? So you arbitrarily assign, listen to these points very carefully. You arbitrarily assign current in, according to your wish, you assign current in the different branches. Suppose I am taking the current here as I1, here as I2, here as I3, this one is I4, this one is I5. you assign arbitrarily direction of the current in each of the branch according to your wish you assign. Okay, there is no hard and fast rule. Okay, I have taken I1 from left to right. You can take it from the opposite in the opposite direction, right to left. According to your wish, you assign current direction, because I do not know whether V1 is greater than E1 or V2 is greater than E2 or V1 is greater than V2, because V1 and V2 are the node potential. Okay, you do not know in which. Suppose V1 will be known to you, then you can surely tell that my current is flowing from E1 to V1. If V1 is less than E1, then the current will flow from E1 to V1. If V1 is greater than E1, then the current will flow from right to left. Okay, so here as V1 is not known to you, that is an unknown value, so you assume it. You assume in any direction, automatically you will get a plus or minus sign. After you get the answer, you will automatically get a plus or minus sign. If I am getting a plus sign, that means the current is actually flowing in the direction in which I have assumed it. Suppose the current, if I am getting a negative sign, then the current is flowing opposite to what I have assumed. Am I clear now? Am I clear now? Got it, all of you?
Yes,
So
ma'am.
here, so you arbitrarily assign current in without any hesitation. You give direction of the current. Otherwise, you cannot apply Kirchhoff's current law. In order to use Kirchhoff's current law, you should be knowing what are the different currents flowing entering into the node, what are the different currents flowing out from that particular node. Otherwise, you cannot use Kirchhoff's current law. So for that purpose, I am telling you, you arbitrarily assign the direction of the current. Automatically, you will get a minus sign, or I will get a minus sign, or you will get a plus sign, or I will get a plus sign. That is a different thing. Okay. So after solving the equations, you will get to know that yes, the current is actually flowing in this direction to this direction. Okay. So using Kirchhoff's current law, write the node equation. Now, so I have assigned the current in each branch. So now what you will do it is write the node equation, solve the node equation to get node voltage. So what you will do? You will solve whatever the equations you have right. How many equations you will get? You have n number of nodes whose potential is not known to you. So you have to write down n number of equation. Am I clear now? How many equations you have to write? You have to identify the nodes whose potential is not known to you. That is your n. One of the node you have to take it as datum node. Okay. And after using Kirchhoff's current law, you write down the node equation, solve the node equation. Automatically, you will have two number of nodes which potential is not known to you, and you have two equations. So you will get the value of the unknown node potential. That is your V1 and V2. Am I clear up to this? Am I clear to each one of you? Yes or no? Got it or not?
Yes, ma'am.
Yes, ma'am.
So here you will tell me how to write down the node equation. That is important. How to write down the node equations. Look at here. So here, look at the diagram and tell me how to write the node equation. For node 1, you will write like this. Whatever the steps I am following, you have to write in proper steps. Okay, so node 1, what is the Kirchhoff's current law? You have to use Kirchhoff's current law. So I can write I1 is equal to how much? I2 plus I4. Yes or no? I1 is equal to, I1 is this one, I1 is equal to I2 plus I4. Now what is the value of I1? Can anyone tell me what is the value of I1? Tell me. I1 is equal to how much?
E1 by R1. E1 by R1.
E1 by R1. Why? E1 by R1. Huh? Tell. What is the value of I1? I1 is what? Current which is flowing in from this point to this point, right? I1 is the current which is flowing from this point to this point. That means
E1 minus V1 by R1.
listen. I1 is flowing from this point to this point. It is so that means what? What we have done? The potential of E1 is greater than V1. I have taken the current in from left to right implies that I have assumed that the potential of E1 is greater than V1. That's why I have taken the current from left to right. If you would have taken the current from right to left, suppose you have taken like this, that means you have assumed that the potential of V1 is greater than E1. Current always flow from higher potential to lower potential. So that means in this case, you have assumed E1 is greater than V1. It may not be. It may not be. Suppose I have solved the node equation and I have got I1 as a negative. That means the current is not actually flowing the direction which I have assumed. The current is flowing from in the opposite direction. So after solving, you will get able to know. But as I have assigned the direction of the current, it implies that I have taken the potential of E1 greater than V1. Am I clear to all of you?
Yes.
Got it?
Yes. Ma'am.
Okay. Yes. So here, what will be your I1? I1, just use your Ohm's law. Ohm's law tells that what? What is the potential difference divided by the resistance will give you the current, right? So I1 will be equal to how much? E1 minus V1. That is the potential difference across this particular branch. I am concerned with this particular branch because the current I1 is flowing in this particular branch only. Okay. So E1 minus V1 divided by how much? R1. Clear to all of you? Is there any doubt? Tell me here.
No, ma'am. Yes, no, ma'am.
Clear? Okay, very good. Girl side, you are clear? Chetna, Chhabi, Pallavi, Ayushi, respond all of you.
Yes, ma'am. Yes, ma'am.
Siddhant, clear?
Yes, ma'am.
Very good. So now come to the value of I2. I2 will be equal to how much? I2 will be equal to same. When you are just apply the Kirchhoff's current law, find out the current by using Ohm's law only. Okay, because resistance is known to you, the potential you have assigned the potential of each node. Okay, whose potential is not known also you have assigned. So use Ohm's law and write down the equation only. Okay, that is potential difference across the two ends in which that current is flowing divided by the resistance. Simple equation. So I2 will be equal to how much? This will be equal to, tell me, Amish, tell me what will be the equation. Amish, tell. I2 will be equal to how much?
Ma'am, V1 minus V2 by R2.
By how much? R2. Very good. So now come to I3. I4. I4 will be equal to how much? The potential of the datum node is 0. The potential of the datum node is 0 volt. So what will be the I4? V1 minus 0 divided by how much? R4. Just you substitute all the values of I1, I2 and I4 in the equation 1. Take it as equation 1. Substitute it. Substitute the values here. All of you do it. I will write down the equation just by looking at the network. I will also tell you this shortcut formula. How will you write down the node equation? Just by looking at the network without using Kirchhoff's current law also. Yes, tell me. Somebody is...
yes ma'am. मैम वो जो 0 वोल्ट लिए रेफरेंस नोड में मैम वो मेरे को थोड़ा समझ में नहीं आया था स्टार्टिंग से.
ये 0 वोल्ट है datum node. ये तो reference node we are taking it as 0 volts. All the node voltages are measured with respect to the reference node. Got it? All the node voltages, suppose this one is 5 volt. This battery is having 5 volts, suppose. That means what? Tell me. This is a 0 volt. This is 5 volt.
Yes,
got it or not?
Yes.
Okay. So all the node voltages are measured with respect to this reference node. That is your datum node, which is at 0 potential.
That datum node every means its voltage will be 0 every time.
Yes, datum node is that we have taken it as reference. All the node voltages are measured with respect to the datum node.
Okay, ma'am, got it.
Okay, yes. So now you substitute and you check it whether you are getting this equation or not. All of you will do it. Whether you are getting this equation or not, you check it. I will tell you I am writing the equation just by looking at the network. I will also tell you how you can write down the node equation just by looking at the network. This is equal to 0. You just check whether you are getting this equation or not. Check, take it as equation number 2. Got it? Okay, you just wait. I will tell you. Now come to the node 2. Node 2, what is the Kirchhoff's current law? Tell me. Node 2, what is the Kirchhoff's current law? Tell me. Quick. Kirchhoff's current law, what is the equation? Tell me.
I2 equal to I3 plus I5.
I2 equal to, very good, I3 plus I5. What is I2? Tell me. Susri Shamya, 841. Tell me. What is the value of I3?
Ma'am, I3 will be
I will be equal to how much? I3 plus I5. Quickly tell. I2 will be equal to how much?
I2.
I2, yes.
Ma'am, V1 minus V2 by R2.
V1 minus V2 divided by R2. Very
R2.
good. Then I3. I3 is equal to?
Ma'am, E2. Ma'am, E2 is larger than V2, right?
Right. Yes, I have taken I3 from which is flowing from E2 to E2. So obviously
And then
V2
V2 minus E2 by R3.
I3 is equal to V2 minus E2 divided by R3.
R3.
What is I5?
I5 will be V2 minus 0 by R5.
Very good. Now substitute it. Substitute all of you and you check the equation whether you are getting this equation or not. R2 plus 1 by R3 plus 1 by R5 minus V1 divided by R2 minus E2 divided by R3 is equal to 0. You check. Take this as equation number 3. Take this as equation number 4. You check. After substituting the value of I2, I3 and I5 in equation number 3, you check whether you are getting this equation or not. Equation number 4. Tell me yes or no.
Yes, ma'am.
Got it, all of you? Got it? All of you understood, or if there is any doubt, even if it is very, very silly doubt, ask me. Everything should be clear here. Yes, tell me. Anybody having any doubt? No one is having doubt.
मैं वो थोड़ा zoom out कीजिएगा.
Supratim, you understood?
Yes, ma'am.
Okay, very good. दिखाई दिया अभी? अभी दिखाई दिया?
Yes, ma'am. Yes, ma'am.
दिखाई दे रहा है और थोड़ा इंक्रीज करो अभी. ऋतुअंकर, शुभम दास, 835. Subham?
835 has left the university.
Okay.
835. Yes, ma'am.
Sasi Prakash, you understood? Sasi Prakash,
Yes, ma'am.
Sami, Shatvik, Sarvajit, Raviraj,
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Premchandra, Priyam.
Yes, ma'am.
Okay. Now I will tell you now how to write down the node equation if without using Kirchhoff's current law, also just by looking at the network you can write down the node equation. Look at here. All of you have written? Written or not? Tell me. All of you have written?
Yes, ma'am.
Yes, ma'am.
Okay. You see, when you are writing the equation for node 1, the equation is the product of the potential of that particular node when I'm writing the potential, writing the equation for node 1. The equation is the product of the potential of that node. I'm writing the equation for node 1. So I will take the product of the potential of that particular node and sum of the reciprocal of the resistances connected to that particular node. Okay, sum of the product of, again I'm telling you, the equation is the product of the potential of that particular node with sum of the reciprocal of the resistances connected to that node minus potential of the adjacent node. What is the adjacent node? Tell me. What is the adjacent node? V2. Minus the ratio of the minus. Okay, minus the ratio of the potential of the adjacent node to the interconnecting resistance. What is the interconnecting resistance? Between V1 and V2, which resistance is connected?
R2.
Minus, then again minus the potential of the adjacent battery. Adjacent, I am using the term adjacent. Okay, so you have to take the node which is adjacent to the node 1 and you have to take the battery which is adjacent to the node 1 minus the ratio of the potential of the adjacent battery to the interconnecting resistance equal to 0. Again, I am telling you.
Ma'am, it will be
Ma'am, E1 by R1 again?
R1 by R1.
Yes, ma'am.
Okay. So again, I am telling you, when you are writing the equation for a particular node, the equation is the product of the potential of that particular node with sum of the reciprocal of the resistances connected to that node minus ratio of the potential of the adjacent node to the interconnecting resistance minus the potential or minus the ratio of the potential of the adjacent battery to the interconnecting resistance equal to 0. All of you got it? Got it, all of you?
Yes, ma'am.
Understood, all of you? Yes, you check. You check whether you are getting the equation 1, take this as equation 5. You check whether you are getting the equation 1 and equation 2 and equation 5 same or not. Are you getting same or not? Tell me. I will write down the steps, how you will write down the equation. All of you got it?
Yes, ma'am.
Yes.
Yes.
Yes, ma'am.
Very good. So now tell me, what is the, just looking at the network and tell me, how will you write down the equation for node 2? So when you are writing the equation for node 2, the equation is the product of the potential of that particular node with sum of the reciprocal of the resistances connected to that node. So what are the resistance connected to that node? R2,
R2, R3, R5.
R3, R5. Very good. So minus the ratio of the potential of the adjacent node to the interconnecting resistance minus the ratio of the potential of the adjacent battery. So here you have to take E2. You don't have to take E1.
Yes,
E1 is not adjacent to node 2. Okay, to the interconnecting resistance. What is the interconnecting resistance? R3, right?
R3.
Is equal to 0.
0.
Simple. Very easily you can write down the equation just looking at the network. Okay. So this is a shortcut method which I am telling you. Clear to all of you?
Yes,
Yes, ma'am.
Yes, ma'am.
Very, very, very good. So here I forgot to mention here, you write down this one as case 1. Nodal analysis for case 1. Now we will go for case 2.
Ma'am,
Tell.
ma'am, don't we need to care about its sign convention while writing this equation?
No need to care about the sign convention while writing the sign convention. Which one? We are taking
The first one.
current. Current.
Yes, ma'am.
Current. I have told you. You have to,
No, ma'am, not current. The battery or the cell connected to.
No. Minus. Yes. You have to take it, you have to see, na, this, in this case, here you see, I have taken E2, I have taken E1, E2. Okay, suppose here this is, where is my circuit? Look at here. This one is E1, given 5 volt. Okay, if you are taking like this is minus 5 volt, right? Because
Yes,
here I have taken the datum node or the reference node as 0 volt. Okay,
yes,
so automatically instead of E1 taking 5 volt, you have to assign your minus 5.
yes,
Here.
okay.
Understood?
Yes, ma'am.
Okay.
Thank you.
Now come to the equation, case 2. Case 2, you write down when a battery is present between two. Tell. Who was asking? When a battery is present in between two.
जो नोड 1 और नोड देख सकती है
हमारा वॉइस कट रहा है क्या और एक बार बोलो. Yes, anybody has heard his question?
No, मैम आवाज आ रहा है अभी क्या मैम? अभी आ रहा है?
हाँ अभी आ रहा है. बोलो.
माइक ऑफ हो जा रहा है तुम्हारा सुप्रसाद.
हाँ यस मैम, मेरा थोड़ा नेटवर्क इशू हो रहा है मैम. तो मैम अभी आ रहा है मैम, आवाज आ रहा है क्या?
हाँ अभी आ रहा है.
बोल रहा था कि जो आप नोड 1 और नोड 2 का ऊपर एक जो शॉर्टकट मेथड बताई मैम, उसका स्टेटमेंट थोड़ा लिख देंगे क्या मेरे को? थोड़ा
हाँ मैं लिख दूंगी.
मेरे को क्लियर नहीं सुनाई दे रहा है कुछ भी आज.
हाँ आई विल राइट डाउन शॉर्टकट मेथड का स्टेप्स में लिख दूंगी. ठीक है. It will take time, na? So I make you understand. So after that, I will write it in the board and I will send it to you. Don't worry. Okay. So here, second case is when a battery source is present in between two nodes. Suppose the same circuit, I will put a battery source in between two nodes. Okay, same circuit, but I have inserted a battery between node 1 and node 2. Here. Okay, so here we are having three sources. One, here we are having three sources. One is your E1. This one is E2. This one is E3. This one is R1. This is R2. This one is R3. This one is R4. This one is R5. Okay. So how will you write down use Kirchhoff's? I have assigned the direction of the current in each each branch. I1. This one is I2. This one is I3. This one is I4, this one is I5. Okay, so here what will be your equation? Tell me. Same equation? Yes or no?
Yes, ma'am.
Yes. So here, while writing this one for node 1, what will be your equation? Node 1, what will be your equation? Tell me. I1 is equal to I2 plus I4, right? So yes. What will be the value of I2? Tell me here. What will be the value of I2? Here I have assigned this is node 1, this is node 2, this is V1, this is V2. Which potential is not known.
By R2.
Yes, tell me.
V1 minus V2 by R2.
V1 minus V2 by R2. How it will be V1 minus V2 by R2? You have another battery here in between the two nodes. Use simply the Ohm's law. Yes, tell me. What will be? So here you tell me what is the potential of this point. So while traveling yesterday in the last class, I have given you a Kirchhoff's voltage law circuit to solve it in simulation. VCE and VAG. I have told you to found it out. You apply your Kirchhoff's voltage law. What will be the potential of, at this particular point? V1 minus E3. Yes or no? Yes or no? All of you understood or not? Here one battery is there. So what will be the potential of this point? V1 minus E3. Got it or not? All of you understood or not?
Yes, ma'am.
V1 minus E3. Then what?
Minus V2.
By very good. Minus V2 divided by how much?
R2.
Now you are clear?
Yes, ma'am.
Okay. So here you will just substitute the value of I2 in this equation and you will write down the node equation. You will see that the equation which you will get is, what was the equation? Just by looking at the network, I have told you what was the equation. V1 whole into R1, 1 by R1 plus 1 by R2 plus 1 by R4 minus how much? V2 divided by R2 minus E1 divided by R1. Okay, this much was there. Without having a battery, the equation was this much. Yes or no?
Yes, ma'am.
So now what you will add? Now what we will add? While writing the equation for the node 1, you will see here whether there is a drop in the potential here or there is a rise in the potential. There is a drop in the potential. So what you will have to write, this another term will be included here, minus E3 minus the ratio of the battery, adjacent battery to the interconnecting resistance. How much? What is the interconnecting resistance? R2. R2 is interconnecting, whether you keep it here or you keep it here. Understood or not? This is a series circuit, right?
Yes.
This is a series circuit. So you have to adjust that. You will substitute all I1, I2, I4, the values in this equation 1 and you check it whether you are getting this equation or not. This will be equal to 0. Am I clear now? What I have done?
Yes,
Am I clear or not?
Yes, ma'am.
Very good.
मैम
Tell.
अभी आवाज आ रहा है ना, क्लियर है?
किसका? सुप्रसाद?
यस मैम.
बोलो.
मैम वो जो V1 माइनस E3 हुआ मैम, वो समझा सकती है माइनस E3 क्यों हुआ?
क्यों हुआ? देखो यहाँ पर तुम्हारा एक ड्रॉप इन पोटेंशियल while your current is moving from higher potential to lower potential.
Yes, ma'am.
I have taken this one. What is the potential here? Tell me. Whatever the current will be flowing, that current will be equal to how much? Potential difference across those 2 points divided by the resistance, right?
Yes, ma'am.
What is the potential difference here?
Ma'am, V1 minus E3.
That's what I have done, na?
Okay, ma'am. Got it.
Got it? Okay.
Yes, ma'am. Yes.
So you just substitute. This is a homework for you. You substitute I1, I2 value has only changed because a battery is there in between the two nodes. You just substitute the value of I2 in this Kirchhoff's current law equation. You check it whether you are getting this equation or not. This one I have used just by looking at the network. I have written the equation. You check it whether you are getting this equation and this equation by putting the value of I2 in this main equation, Kirchhoff's current law equation. You check this equation and this equation whether you are getting the same equation or not. You will check it. Understood, all of you? Got it or not?
Yes, ma'am. Yes, ma'am.
Yes. You check it and tomorrow class you tell me whether you have got the same equation or not. Now for node 2, tell me what was the equation? Just by looking at the network, tell me what was the equation? 1 by R2 plus how much? 1 by R3 plus 1 by R5 minus how much? Ratio of the adjacent node to the interconnecting resistance minus ratio of the adjacent battery to the interconnecting resistance. What is the interconnecting resistance? R3. Then what you have to do while writing the equation for node 2, Here, what will be the equation? Extra equation will be how much? Extra term will be. While looking at here, this is at higher potential. Yes or no?
Yes,
This is at higher
you will
potential.
plus it.
Yes. So
Ma'am,
here
plus-
it will be plus
E3
E3 divided by R3.
R3.
Simple one extra term will be added here. Got it, all of you?
Yes, ma'am.
Suprasad Bujhela? Understood or not?
आ गया मैम, बुझिएगा.
Okay. So your work is, your homework is, you will just substitute the value of I2 because I2 is only changing. You substitute with the main Kirchhoff's current law equation. Check whether you are getting this equation or not. This is equation 7. This you take it as equation 8. Whether you are getting the node 1 equation, this one or not, node 2, this one or not. Okay. This is case 2. Any doubt with this?
मैम मैम जो थोड़ा मैम ऊपर लेंगे क्या मैम? जो ऊपर में -E3/R3 हुआ वो वाला थोड़ा बता देंगे क्या? वो वाला, ये सेकंड वाला समझ में आ गया, पॉजिटिव जो रहा.
कहाँ पर -E3/R3?
मैम जो एक्स्ट्रा टर्म एक ऐड हुआ ना नोड 1 में.
When you are staying at potential at node 1, this is at lower potential. When you are writing the equation for node 2, this is at higher potential.
Okay, ma'am. Okay.
Okay.
Yes.
So
मैम
now,
इसको मैम
tell.
E3/R2 होगा ना?
हाँ, R2. Very good. Thank you. E3 divided by R2. Yes. Thank you. This will be not R3. Interconnecting distance is R2. Good.
मैम एक बार मैंने सर्किट में दिखा R3 के R2 कैसे हो?
R2 तो इंटरकनेक्टिंग डिस्टेंस ही R2 है ना.
मैम एक बार सर्किट
बीच वाला रजिस्टर कितना है? R2 है ना. दिखाई दिया?
Yes, ma'am. Yes, ma'am.
Now come to the last case. Case 3. Case 3 is nodal analysis with current source. Nodal analysis with current source. Current source. Now here I will take two current source. So here I have taken two current source. One is your I1, another one is your I2. Three resistance are there. This is R1, this one is R2, this one is R3. Now here you tell me how many nodes are there whose potential is not known to you. Quick. This is your datum node?
Yes, ma'am.
0 volt. How many nodes are there? Tell me. How many nodes are there?
Ma'am, 2.
2. This is one node. This is a single node. 1. This is also a single node. This is your 2. Okay. So here you assign V1.
मैम नोड तो एक पॉइंट होता है ना.
हाँ, ये तो सेम पॉइंट है ना. यहाँ पर कैसे नोड हुआ? यहाँ पर कैसे? ये तो वो एक ही पॉइंट है ना.
यस मैम.
समझ में? हाँ. So this is node 1. This one is node 2. That's why I have put it a circle. Na? This is single one. Got it? Single joint.
Yes, ma'am.
So this is node 2. Okay. So you same thing here. You arbitrarily take direction of the current. Use Kirchhoff's current law and find out. Okay. Or you take this was an I1, I2. Na? They take this as I3. This one as I4. This one as I5. So what will be the equation here? Kirchhoff's current law. I1 will be equal to how much? I4 plus how much? I3.
I3.
Yes or no? For node 1, this is your equation. What is your I4? I4 can I write down as V1 minus V2 divided by how much? R3.
R3.
What is your I3? I3 will be equal to V1 minus the decam node potential divided by R1. Clear or not?
Yes,
Got
ma'am.
it? So just by looking at the network, I will write down the equation and you will put all these values in equation number 1 and you check it whether you are getting the same equation or not. So while writing the equation for node 1, the equation is the product of the potential of that particular node with the sum of the reciprocal of the resistances connected to that node minus the potential of the minus the ratio of the potential of the adjacent node to the interconnecting resistance. Adjacent battery nahi hai, there is no adjacent battery, so this will be equal to the value of the current source. This is equal to the value of the current source. Here you see voltage by resistance is what? Current. So it will be equal to the value of the current source and is positive. Listen to me carefully. And is positive if the current in the current source is going to the node. Okay, if it is flowing out from that node, then you have to take it negative. Am I clear to all of you?
मैम एक बार फिर से
This equation is clear. Product of the equation is the ratio, the product of the potential of that node with the sum of the reciprocal of the resistance connected to that node minus the ratio of the potential of the adjacent node to the interconnecting resistance will be equal to the value of the current source and is positive if the current in the current source is flowing towards that node. Am I clear? Simple. Only I have added a current source and it is positive because the current in the current source is flowing towards the node.
Yes,
Clear now? What is similarly? Only small difference is there. Now tell me for the node 2. Node 2, what is the equation? Tell me. Just looking at the network, you tell me. Look at the network and tell me. So many times I have told you V2 multiply with how much? 1 by
R2 plus 1 by R3.
Very good. Minus
V1
V1 divided by how much?
R1.
R1
V1 divided by R1 or R2?
R3.
R3.
R3
क्या तू सॉरी क्या बोल रहे हो? लिख नहीं रहे हो क्या? तुम्हारा कॉपी से R3 then will be equal to the value of the current source
minus I2.
Okay, same thing also here I am telling you. Here what you will do it is you will use Kirchhoff's current law. What is your node 2 equation? Node 2 equation using Kirchhoff's current law. Tell me, what is your node 2? I4 plus I5 is equal to capital I2. Yes or no? What is your I4? I4 is your V1 minus V2 divided by how much? R3.
R3.
What is your I5? I5 is your V2 minus 0 divided by R2. Right? You substitute all the values here. Check whether you are getting the, which I am using the shortcut method here. You check it whether you are getting the same equation or not. Okay? Clear? This equation and this equation, you will put all those values in equation 1 and equation 2 and you check it whether you are getting the same equation or not. Am I clear to all of you or not?
Yes, ma'am.
Yes, ma'am.
Difficult लगा क्या?
No, ma'am.
No, ma'am.
No, ma'am.
ये तो easy. Okay, next class we will do problems.
मैम एग्जाम में शॉर्टकट मेथड कर सकते हैं ना?
हाँ, अरे very easily तुमको बहुत सारा problem